Okay, today we're going to be trying to answer the question, is sucking the opposite of blowing? And actually, this question has been puzzling physicists for over 50 years. Let me show you why. To show you what I mean, let me do an experiment that has to be one of the easiest ones I've ever done on my channel. So grab a curved straw like this and blow into the end of it and watch what happens. So you can see that when I blow in it, it gets pushed back. And the reason this happens is because as the air moves down the straw, it has to change direction to go that way. But in order to change direction, it has to change the direction of its momentum. And so in order to get the momentum moving that way, it has to push off of something. And so it has to push off the back of the straw. And since it pushes off the back of the straw, it sends the back of the straw that way and the air that way. And so there's a recoil as the air flows out of it. This is the same reason why it's so hard to hold a fire hose with a bunch of water coming out of it. Because the water has to change direction from coming up and it has to go out. So it has to push off of something to change its direction, and it has to push off the hose or you holding it. In order to see this effect a little better, I have this cool device here. So this is basically just like the straw, but it has a little fin on it. And so this is like the tube here and it has the bend here. So the air comes down here and it bends and it goes out that way. And so when you blow in the middle here, air comes out all of these sides here and gets pushed that way. And when it gets pushed that way, it pushes the fin this way. So watch what happens when I blow in it. It's hitting my big nose, but you can see what's happening. And so what's really cool with these things is if you stick a balloon on it, the balloon blows air out of it and it starts to spin, and it basically creates a little helicopter with the balloon. Okay, here we go. 3, 2, 1. Whoa. So not only can this motion make balloons fly, but it also is the same motion that makes sprinklers turn around in circles, because the water's coming up and out of the sprinkler, and so it pushes the metal of the sprinkler the other way, and so it turns the sprinkler as the water's spraying out. And here we get to one of the greatest physics debates of all time. It's called Feynman's inverse sprinkler problem. And it was proposed by Richard Feynman, one of the greatest physicists of all time. And what he said is that we all know that a sprinkler, when it sprays water out, it turns this direction. But the question is, if you're able to suck water into the sprinkler, would it go the opposite direction? So let's go ahead and try it with my straw here. Okay, so here it is blowing again. Obviously goes backwards because the air is coming down, hitting the elbow, pushing it back this way as the air goes out. So as I'm sucking it in, some physicists propose that it should just go the opposite direction because the air is now coming in this way, so it's as if you're blowing down into the straw and it's hitting that corner there and going this way. So as it hits this corner, it's gonna knock it this way. So it's gonna go the opposite direction. So let's see if that happens when I suck in now. Nothing. It's kind of hard to tell because when I suck in, my lips move it, and it's kind of just moving it back a little bit. But it's definitely not getting that opposite recoil and going the different direction. We can see it a little bit better when we use this device here. So here's what it looks like when I blow it again. So as I suck in, the air is going to be going this way, and some physicists propose that it should hit that elbow there and make it recoil and go this way. So it's going to come in, deflect the air down that way, so it should push this way and make it turn a little bit. So let's see what happens when I suck in. Nothing. So blowing, sucking. So that is pretty confusing. Why is that happening? So first, in order to see if this was true, what Feynman did is he took a sprinkler and put it in a big cylinder and filled it with water, and then he put compressed air in the cylinder and saw if he could force the water to go into the sprinkler and saw if it spun the opposite direction. And what happened is it didn't spin the opposite direction. It just stood there still. But some other physicists at MIT, they weren't satisfied with that experiment, and they did a proper experiment, but instead of using water, they used air. And they saw the same results that I'm seeing here. They saw that when they were sucking air into it, it didn't spin the opposite direction. But then a professor from the University of Maryland wasn't satisfied with those results either, because he thought that it should be a different result that should make it go the other direction. And so he published his results in the American Journal of Physics, showing that actually, if you do it proper and account for turbulence and friction, it does move in the opposite direction. But not in air, only in water. So does that actually mean that sucking is the opposite of blowing? Well, I still propose that no, it's not. Let me show you a few different reasons why. So if you've ever stood in front of a fan, you can feel that air just rushing in front of your face, blowing your hair. But what happens when you walk around to the back of the fan? It's not like your hair just suddenly gets sucked in and you're getting sucked into the fan and you just feel that air rushing past you at all. In fact, you don't really feel anything at all. You can put your hand in front of the fan, you easily feel the air, but when you put your hand in back of the fan, you hardly feel anything. So why is that? Isn't the same amount of air going into the back of the fan as coming out the front? It has to be. But why can't you feel it? So the reason that you feel air when you put your hand in front of a fan but don't feel it when you put it behind the fan is not because there's not air flowing past you, but it's because the direction that the air is coming. So in the front of the fan, the way the blades direct the air is very directional, and it has a high velocity in a small area. But in the back of the fan, even though there's the same amount of air coming in, there actually is not a very strong direction to it. It's kind of coming from all directions. So if you took the amount of air in the back of the fan per area and the air in the front of the fan per area, you'd get the same amount. But when you stick your hand and try to fill it, you only have a finite area, a small area to fill it, and so you can only fill a small bit of air, whereas that same area in the front of the fan can fill a lot of air. So you can see that the way a fan flows, you can see that there's different in blowing and sucking. And you can understand what I mean a little bit better with a slightly different experiment using a shop vac. So with a shop vac, you have one side that blows out air and one side that sucks in air. So you can see the difference between sucking and blowing here. So I have a cotton ball in my hand, and watch what happens when I hold it a few inches from the outlet of the blower. It easily blows it out of my hand. But now watch what happens when I put it a few inches from the sucker. Nothing, it can't suck it in. And the reason is the same as the fan reason that I told you before, because when it's coming out of the blowing end, it has a very strong direction to it. And that direction can carry out for a long distance and it can blow something out of my hand. Whereas on this side, the direction that it's sucking in the air is coming from all over. It's coming from up here, going in, up here, down here. It's not just coming from right in front of it. But if you were to confine the area to the same area, then you'd easily see the same force. So these areas of these two pipes here are the same. And so if I put it on the blowing end right here, it blows it out. And when I put it on the sucking end right here, it easily sucks it in. So you can see that as soon as you confine the area, then you get the same flow whether you're sucking or blowing. And that should make perfect sense, because when you see a fluid flowing through a tube, so one side of it is being pushed and the other side of it's getting pulled, but it doesn't really matter because it's all confined to the exact same area. And so whatever's in front or behind, it's all moving the same. So that means that sucking and blowing are very different unless you confine them to the same area. But that's not all. Not only is it different because of the different areas of air coming in, but it's just different in the total amount of force that you can get out of blowing versus sucking. So when you're sucking something in, the maximum pressure difference you can get between the thing that's doing the sucking and the outside air is only 1 atmosphere. Even if I have an extremely strong vacuum pump, a turbomolecular pump that's pumping down the pressure to 10 to the negative 12 pascals, it actually doesn't change the overall pressure on the sides of the container here much more than just having it at 0.01 pascals or something. And that's because the overall pressure difference can only be 1 atmosphere no matter what. But the same is not true for pressure. For pressure, you can keep pumping something full of more and more gas until it gets to whatever amount of pressure you want. And so the danger of something exploding is much greater than something imploding, because you can get a very great difference between the internal pressure and the pressure of the atmosphere. You can get to hundreds or thousands or tens of thousands of atmospheres of difference of pressure. And that's not all. Even if we're talking about the human body, how hard we can suck in versus how hard we can blow out. You can't actually suck in that hard at all, but you can blow out a lot. And you can see that's true if you ever go into a pool and get a long tube or a long snorkel or something and try to breathe in more than a few feet of water. It's actually really hard to get yourself to suck in enough air to even expand your lungs enough to take a breath. That's why snorkeling with long tubes doesn't work at all, because the hydrostatic pressure of the water just compresses it just enough, compresses your lungs or your chest just enough that you can't even take a breath in. So your diaphragm is actually really weak when it comes to taking a breath in, but it's really strong when it comes to pushing out air. So my final conclusion, sucking is not the opposite of blowing. It's different for the human body. It's different in the amount of pressure that you can get, the difference in pressure between the thing that's doing the sucking or blowing and the atmosphere. And also it's different in the amount of airflow. Okay, everybody, thanks for letting me get that off my chest. I hope you enjoyed this video. If you did, remember to hit the subscribe button and click the bell to be notified when my latest video comes out. I'm always looking at your comments and I like hearing you comment or ask me any questions that you have in the comments section. And if you haven't headed over to theactionlab.com, head over there now and check out my new subscription box. You can actually get your very own vacuum chamber. Thanks for watching and I'll see you next time.